Hey guys, this is Mr. Grice for Algebra 6.3 Notes. Today we're talking about graphing basic exponential growth functions. Our learning objective is to be able to graph basic exponential growth functions. Now, before we get started though, I got a question for you. I'd like you to imagine that the state lottery is having a special for the month of February called Pick Your Prize. And to be honest with you, this actually happened. Winners will get to choose from two options. One, you can get paid $40,000 each week for the full month of February, or you can get paid a penny the first day of the month, 2 pennies the second day, and have the quantity doubled every day thereafter for the entire month of February. Which option would you pick? Now, before you grab a calculator, think in your mind, what's the better deal? $40,000 a week for 4 weeks, or having a penny the first day, and then the second day you'd get 2 pennies. The third day you'd get 4 pennies. Okay, I want you to think about that real quick. Think long and hard. Am I trying to trick you or not? Think about it. Okay, did you decide what you want to do? Cool. What was it? You can tell me. Really? That's what you want? Sure. All right, well, let's figure it out. So, grand totals. For the first week, for the $40,000 option, you'd get $40,000. And for the penny option, you'd get $1.27. Like, Mr. Grice, how'd you get $1.27? Well, let's think about it. So week 1, there are 7 days in a week, right? So day 1, day 2, day 3, day 4, day 5, day 6, and day 7. Okay? So in that first week on day 1, you'd get a penny. And how would you write a penny down? Don't be saying 0.1. If we're talking about money, it's 0.01. Well, then we times that by 2, and we get 0.02. But then you times that number by 2, and you get 0.04. And then you keep timesing it by 2, and each day it's getting bigger. Like, Mr. Grice, how did you get that? Well, I'll show you how I got that. Just in your calculator, start with 0.1, times it by 2. That's day 2. There's day 3. There's day 4. Day 5. Day 6. And there's day 7. And the reason why we got $1.27 is you take all that money and you add $1.27. So, first week, guess what? $40,000 option sounds a lot better. Well, what about the second week? Well, the second week, boom, you get $80,000 because it's your $40,000 plus another $40,000. Well, what about week 2? Okay, now we don't have to sit here and continue adding it up, but this would be day 8, day 9, day 10, 11, 12, 13, 14. And when you add all that money up, $163. Are you even close to how much they made in the first week yet? Nope. What about week 3? Well, week 3 for the top one, it's another 40,000. You're getting $120,000 in 3 weeks. You could almost buy a house. What do you think the third week would look like? Because look at this. This is 15, 16, 17, 18. Whoa, that money's getting 19, 20, 21. Are we even close to what they made yet? Not so much. So even 3 weeks into this, you're not making as much as they did in the first week. Well, fourth week, $160,000. That's some pretty good money. But in the penny option, what do you think the total is going to be? I know in class someone was thinking like, maybe $70,000. I'd say $70,000 sounds good. But you know what the grand total really is? Over $2 million. Imagine that. Watch this. 20,000. Boom, 40,000. 83,000. And it keeps doubling and doubling. And see how fast this money is piling up? It goes really fast. This is what exponential growth is talking about, okay? In the linear equation, okay, it's constant. Y equals mx plus b, okay? You see equations like y equals 2x plus 3, okay? This is linear. What we're going to be talking about today is exponential. And that's where it would look like y, and we're going to talk about this formula in just a second, where it looked like y equals, what was the example we wrote down? 2 times 3 to the x, okay? And where it starts off real, your graph starts like, oh, you made a little, you made a little, you made a little, and then it, boom, it shoots up really, really fast, where a linear equation is just a straight line, okay? Now, this is something that you can try with your parents with your allowance. Say like, hey, instead of making $10 a week, how about you pay me a penny and double it for a month? See what they say. I'd love to hear it. So, but today we're talking about graphing the basic exponential growth. So the linear equation, which we just talked about, means that the y value changes by the same number by addition or subtraction. And these are the types of problems that we've been working with all semester so far. Okay? But now, the exponential ones, your equation looks like this, y equals a parentheses b to the x. But it's the same thing where the y values change by the same number, but instead, this time it's being multiplied or divided. Okay? So let's take a look at an example right here. The key thing is to look at the y values. Okay? So when we're looking at the y values from 0 to 2, what did it increase by? Well, it increased by a positive 2. And from 2 to 4, we increased by 2. From 2 to, or 4 to 2, 4 to 6, it increased by 2. And it increased by 2. Okay? So when we graph this equation, you can graph it right now too. We're starting at negative 2, 0, 1, 2, 0, 4, 1, 6, 2, 8. Okay, we get to see that what our equation looks like. There we go. So it's a straight line. Do you know what the slope of this line is? Remember, to find the slope, you pick any point and you just count it. And the slope is 2 over 1 or 2. And if you look at it, that's what we're increasing by each time. What about on the right for our exponential growth? Can you tell? Oh, it's kind of hard to tell right there. But what about 1 to 2? And remember, it can either be multiplied or divided. What about 2 to 4? Can you think about it? Well, 1 times 2 is 2. And 2 times 2 is 4, and 4 times 2 is 8. And technically 1/2 times 2 gives us 1. So in this graph, everything's being multiplied by 2. Okay? Now, let's take a look to see what this graph looks like. So I know -1 and 1/2 might be kind of hard to graph, but do your best. 0, 1, 1, 2, 2, 4. Oh, that's not 2, 4. And then 3, 5, 6, 7, 8. Okay? Now, what you notice, this graph kind of curves up. Now, as this graph curves up, you want to make sure it's a curve, okay? And the thing with this one, when you're graphing it, it never touches the x-axis. Never. Okay, so when you're drawing this, I want you to get close, but never touch it, okay? And that's called the asymptote, okay? It never touches the asymptote. All right. Now, talking about the domain and range. We've talked about domain and range before, okay? The domain is your x and the range is your y. Where before we were just like, hey, what's the domain? Oh, the domain, oh, it's -2, -1, 0, 1, and 2. Well, true, but that's not what it always is, okay? From left to right, what are all the possibilities that x could be, okay? So x, well, there's no stopping because see the arrows? The arrows means it goes on forever and ever and ever and ever and ever, which means for x from left to right, it can be all real numbers, okay? And that's the key thing about the arrows. And now when we're talking about up and down, your y values, your range, it's the same thing. There is no stopping it, okay? It can be all real numbers. Now, let's take a look at here. On our graph from left to right, does it ever stop? Can we keep going to the left, left, left? Well, yeah, that's the direction the graph's going. And we can keep going to the right, right, right as far as we want to, okay? So the x, the domain, it's actually the same. It can be all real numbers. But now when we're talking about the y, our range, it can go as high as we want to, but remember, it can't cross the x-axis. So if it can't cross the x-axis, it's never, ever going to get to 0. So the difference for this one is that y is greater than 0. Okay? Now, if that part didn't make a lot of sense, that's okay. What that right there is for people who are going to be going into advanced algebra, their junior years, advanced algebra 2. That's just a little taste of what you would see. Okay? All right, so let's take a look. Determine which table of values represents a, what are we looking for? Linear function, and which represents an exponential function. Explain your answer by using complete sentence. All right, so what we want to do is we want to look at the y values and what's happening to them. All right, so for table A, 3 to 0, what happened there? 0 to -3, -3 to 6. Do you start seeing a pattern how the numbers are getting smaller, right? And so we're subtracting, and you're subtracting 3 to all of those. Okay, but what about B? What's going on to 1/3 to 1? Or from 1 to 3? That you might start to see from 1 to 3, and from 3 to 9, and 9 to 27. It's the same pattern each time. What's going on is you're multiplying that number by 3. Okay, so this is what something would look like, or how you would say this. We would say that table A represents a linear function, okay, because the y values are, what's happening to the y values? Are being subtracted by 3. See, every single time it's being subtracted by 3, subtracted by 3, subtracted by 3. And remember, that's what we said at the very top, that a number is added or subtracted each time. Okay? And now continuing on, we have to say that table B represents an exponential function, and that is because the y values are multiplied by 3. Okay? That's something we expect you to write and being able to verbally tell us. Okay? All right. Well, guys, I'm going to pause this video right here just because it's getting kind of long. So this will be the first part of the notes, video 1, and then video 2 will go through the rest of the examples. Okay? So stay tuned.